Hi students, welcome to Sankalp Study Success. Today in this video, I am going to solve very important question based on Gauss-Jordan method for 4 by 4 matrix. This question has been repeated many times. Okay, now let's start the class. Before solving the problems, let's revise the steps that are used to find the inverse of a matrix. So these are the steps we have already seen in the previous video. This is a 4 by 4 matrix. So what is the first step? I have to make this A11 is equal to 1 by swapping with any other row which has got the first element as 1. Next, we have to make these three elements 0, making use of A11. Next, what is the next third step? We have to make these three elements 0 by making use of A22, second diagonal element. In the same way, the fourth step is we have to make use of third diagonal element and make these three elements 0. And the last step, that is fifth step, is we have to make use of the last diagonal element, that is A44, in order to make these three elements 0. So in order to make the remaining elements 0, we are using the diagonal elements A11, A22, A33 and A44. And these diagonal elements should be made 1. Now, what is the general form of the Gauss-Jordan method? It is A is equal to In into A, where In is called as identity matrix of order n, or it is also called as prefactor. And in this Gauss-Jordan method, we should apply only row operations to both left-hand side and right-hand side. So after applying the row operations, the matrix will be reduced to this form. In is equal to B into A, where B is the called as inverse of the matrix A. That is, B is the final answer. Is that clear, students? Now we shall get back to the problem. So this is the problem, 4 by 4 matrix. Find the inverse of the following matrix using Gauss-Jordan method. It is given in 2005. Now let's start the problem. First, write down the general form of the Gauss-Jordan. That is, A is equal to In into A. Okay, students. Now what is A? That is the given matrix. So 0, 1, write down the given matrix here. 1, 1, 2, 3, 2, 2, 2, 3 and 2, 3, 3, 3. Okay, since it's a 4 by 4 matrix, I will write down the identity matrix In as 4 by 4. That is 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1 into A. So this is the general form of the Gauss-Jordan method. Is that clear, students? Now, what is the first step? First step is we have to make this element 1. This is 0 here. So in order to make this element 1, I should swap the first row with the second row, because the first element of second row is 1 here. So what will be the operation? I will swap this first row with the second row. And whatever the row operations we are doing, it should be applied to both the matrices, left hand side and right hand side. So now what will be the new matrix now? 1, 1, 2, 3. 0, 1, 2, 2, 2, 2, 2, 3 and 2, 3, 3, 3 is equal to, now we have to swap this right hand side matrix also, that it becomes 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0 and 0, 0, 0, 1 into A. Okay. Now, what is the second step? I should make these three elements 0 by making use of A11. Okay, this element is already 0. So, it is enough if I make these two elements 0. How will you make it? I should multiply the first row with 2 and then subtract from R3 and R4. So that these two will be made 0. Okay, I will explain here, students. See, R3 implies R3 minus 2R1. Okay, and R4 implies R4 minus 2R1. Okay, I will explain this here, calculation part for left hand side and also for right hand side. Okay, for left hand side, first let's see what is this operation. Okay, what is R3? R3 is 2, 2, 2, 3 and I should multiply R1 with 2, that is 2, 2, 4, 6. Okay, so this is R3 and this is 2R1. I should subtract these two. Okay, 2 minus 2 is 0, 2 minus 2 0, 2 minus 4 minus 2 and this is minus 3. Now, what is the second operation for fourth row? Left hand side only. Okay, so what is R4? It is 2 3 3 3. Okay, this is R4. And what is the first row? It is first row I should multiply with 2. That is 2 2 4 and 6. This is 2R1. Okay, and I should subtract this. So 2 minus 2 0, 3 minus 2 1, 3 minus 4 it is minus 1, and this is minus 3. Next, coming to the right hand side. Coming to the right hand side operation. Right hand side, what is the matrix? It is an identity matrix. So what is the third row? It is 0 0 1 0. This is third row, and I should multiply the first row with 2. That is 0 2 0 0. Okay, this is 2R1, and I should subtract these two. It is 0 minus 0 0 minus 2 1 and 0. Okay, now what is the second operation? It is for fourth row. Okay, what is the fourth row for right hand side matrix? It is 0 0 0 1. This is R4, and again I should multiply the first row with 2. That is 0 2 0 0. This is 2R1. Okay students, so I should subtract these two now. 0 minus 2 0 and 1. Now I will replace these two rows with the values I got. Now what will be the first row? The first row and second row remains the same. So that is 1 1 2 3 0 1 2 2. Okay, the third row is 0 0 minus 2 minus 3, and the fourth row is 0 1 minus 1 minus 3 is equal to, now what we got for identity matrix? Okay, these two identity matrix. Okay, so the first and second row remains the same. 0 1 0 1 0 0 1 0 0 0. What is the third row? What are the new elements? 0 minus 2 1 0, and fourth row is, it is 0 minus 2 0 1. Is that clear students until now? Into A. Now what is the next rule? What is the next rule? I have to make use of this second diagonal element and make these three elements 0. Okay, this element is already 0, so it is enough to make these two elements 0. For that, I should subtract R1 and R2, and I should subtract R2 and R4. Okay, I will write down the operation here. R1 implies R1 minus R2, and R4 implies R4 minus R2. Okay, now I am doing it here students. Okay, for left hand side I am doing it here. This is for left hand side, and this is right hand side matrix. Okay, what is first row? That is 1 1 2 3. This is R1. And what is R2? 0 1 2 2. Okay, this is R2. Now subtract these two. 1 minus 0 is 1. Sorry, 1 minus 0 is 1. One minus 0 is 1. 0 0, and it is 1. Okay, now for the left hand side, what is the fourth R4 operation? It is R4 minus R2. R4 minus R2. What is fourth row? It is 0 1 minus 1 minus 3. This is fourth row. And what is second row? It is 0 1 2 2. This is second row. Now I should subtract these two. 0 0 minus 1 minus 2 is minus 3, minus 3 minus 2 is minus 5. Now coming to the right hand side matrix. For right hand side matrix, I should perform the same operations, R1 minus R2 and R4 minus R2. Now what is first row of second matrix? It is 0 1 0 0. This is R1, and R2 is 1 0 0 0. So this is R2. Okay, I should subtract these two. It is minus 1 1 0 0. Now coming to the R4 operation, it is R4 minus R2. Okay, what is fourth row? 0 minus 2, 0, 1. This is R4. And what is second row? 1, 0, 0, 0. Okay, this is R2. And I should subtract these two. 0 minus 1 is minus 1, minus 2, 0, and 1. Okay, so now let us substitute all these values in the matrix. So the first row, what is the first row answer for left hand side? It is 1, 0, 0, 1. And second row remains the same 0, 1, 2, 2. Third row is 0, 0, minus 2, minus 3. And what is the fourth row? It is 0, 0, minus 3, minus 5. Is that clear, students? Is equal to, now what are the new elements for right hand side matrix? The first row is minus 1, 1, 0, 0. Okay, the second row remains the same, and also the third row remains the same, and fourth row it is minus 1, minus 2, 0, and 1. This is into A. Yes. Next, what is the next step? I should make use of the third diagonal element. I should make use of this third diagonal element and make these three elements 0. Okay, that means I should add R2 and R3 because this is a negative number, right? So I should add R2 and R3 in order to make this element 0. Okay, and for this I should multiply. I will tell you for this row, I will tell you the operation. First let me write this. R2 implies R2 plus R3. Okay, now for R4, see students, for R4 I should multiply this by 2 and this by 3 so that the element becomes 0. So it is 2R4 minus 3R3. Okay, now again coming to the calculation part here, LHS and RHS. Okay, left hand side matrix, what is R2? It is 0, 1, 2, 2. This is R2. Now what is R3? 0, 0, minus 2, minus 3. This is R3. I should add these two. Okay, 0 plus 0, 0, 1 plus 0 is 1, 2 minus 2, 0, 2 minus 3, it is minus 1. Now what is the second operation for fourth row? This. So what is this? It is 2R4 minus 3R3. Okay, 2 into R4. Okay, 2 into R4, that is 0, 0, minus 6, minus 10. This is 2R4. And 3R3, it is 0, 0, minus 6, and I should multiply the 3 minus 9. Okay, so this is 3R3. Okay, I should subtract these two. 0, 0, minus 6. When I subtract minus 6, this becomes 0. Okay, and minus 10 plus 9, it becomes minus 1 here. Next, coming to the right hand side. R2 plus R3. What is R2? It is 1, 0, 0, 0. And what is R3? It is 0, minus 2, 1, 0. Okay, and I should add these two. This is R2 and this is R3. Okay, 1 minus 2, 1, 0, since it is an addition. Now coming to the second operation for the fourth row, 2R4 minus 3R3. Okay, 2R4. For right hand side it is 2R4 minus 3R3. Okay, fourth row I should multiply with 2, that is minus 2, minus 4, 0, 2. Okay students, next what is 3R3? 0, minus 6, 3 and 0. Okay, is that clear? I should subtract these two, that is this is minus 2, minus 4 plus 6, it is 2, 0 minus 3 is minus 2, and 2 minus 2 is 0. 2 minus 0 is 2. Now I will replace this. 1 minute, students. Let me check this once again. 2 r4 minus 2 minus 4 0 and 2. Okay, and 3r3 0 minus 6 3 and 0. Okay, it is minus 2 minus 4 plus 6, it is 2. 0 minus 3 is minus 2. Okay, it is correct. Okay, I will substitute here R2 and R4. So R1 is the same 1 0 0 1. For R2 I got it as 0 1 0 minus 1, and R3 remains the same, that is 0 0 minus 2 minus 3, and for R4 the new elements are 0 0 0 minus 1. Okay, is equal to, okay, for the right hand side matrix, the first row 1 1 minus 1 1 0 0. Second row I got it as 1 minus 2 1 0. The third row remains the same again, 0 minus 2 1 0. And the fourth row is minus 2 2 minus 3 2. This is into A. Now next. Okay, now I have to make use of the fourth diagonal element, and I should make these three elements 0. Is that clear, students? For that, what will be the operations? R1 implies R1 R1 implies R1 plus R4. Okay. Next, R2 implies R2 minus R4, and R3 implies R3 minus 3R4. Okay, so now let's see the calculation part for both the matrices. This is for LHS and this is for RHS. Okay, so first one is R1 plus R4. Okay, so what is the first row? It is 1 0 0 1. This is R1, and fourth matrix it is 0 0 0 minus 1. Okay, so this is 4. Now I should add these two. I should add these two. That is 1 plus 0 is 1 0 0, and this again becomes 0 1 minus 1. Now what is the second operation? This is the second operation, right? So second operation, that is R2 minus R4. So what is R2? It is 0 1 0 minus 1, and R4 it is 0 0 0 minus 1. So I should subtract these two. Okay, 0 1 0 minus 1, minus of minus 1, that is 0 here. Okay, next, R3 minus 3R4. R3 minus 3R4. What is R3? 0 0. It is 0 0 minus 2 minus 3. Okay, now 3R4. I should multiply the fourth row by 3. That is 0 0 0, and it is minus 3. Okay, so I should subtract these two. 0 minus 0 0 minus 2, and this is 0. Minus 3 minus of minus 3 is 0. Now for the right hand side matrix, see students, R1 plus R4. R1 plus R4. So what is the first row? It is minus 1 1 0 0. This is R1. And what is R4? It is minus 2 2 minus 3 2. This is R4, and I should add these two. Okay, I should add these two. So 1 minus 1 minus 2, it is minus 3. 1 plus 2 is 3. 0 minus 3 minus 3, and this is 0 plus 2 is 2. Now what is the second operation? R2 minus R4. What is R2? 1 minus 2 1 0 Okay, so this is R2 and R4 is minus 2, 2 minus 3, 2. So this is R4. Okay, students. Now I should subtract these two. Okay, minus 1 plus 2 it is 3, minus 2 it is minus 4, 1 plus 3 it is 4, and 0 minus 2 it is minus 2. Yes, next. What is the last operation? It is R3 minus 3R4. Okay, what is the third row? Third row is 0, minus 2, 1, 0. And I should multiply fourth row with 3. That is minus 6, 6, minus 9 and 6. Okay. So, and I should subtract these two. I should subtract. So, 0 plus 6 is 6. Okay, minus 2 plus 6. It is 4. Okay, 1 plus 9. It is 10. And 0 minus 6. It is minus 6. Is that clear, students? Okay, let me check once again this operation. This calculation, let me check. It is 0 plus 6 minus 2 minus 6. It doesn't see here. It's wrong. It is minus 2 minus 6 minus 8. Okay, 1 plus 9, 10. 0 minus 6 is minus 6. Okay, now let me write these elements now. The first row, what we got? The first row is 1, 0, 0, 0. Second row, what we got? 0, 1, 0, 0. And third row, it is 0, 0, minus 2, 0. And what is fourth row? It is 0, 0, 0, minus 1. Okay, now it is equal to what we have got here. The first row, minus 3, 3, minus 3, 2. It is 3, minus 4, 4, and minus 2. And R3, what we have got R3, it is 6 minus 8, 10 minus 6. Okay, and the last one is minus 2, 2, minus 3, and 2 into A. Okay. Is that clear, students, until now? Now, see here. So, all the steps we have completed, but still the third diagonal element is not 1 here. It is minus 2, and here it is also not 1. It is minus 1. So, what we have to do here, operation, that is R3 implies R3 by minus 2. If I divide with minus 2, that element will become 1. In the same way, if I multiply R4 with minus 1, then it becomes plus 1. Okay, now see here, 1 0 0 0 0 1 0 0 0 0, minus 2 by minus 2 it is 1 0, and 0 0 0 minus 1 into minus 1 1 is equal to the same operation I should perform for the right hand side also. So the first two rows remains the same, minus 3 3 minus 3 2, 3 minus 4 4 minus 2, and I should divide R3 by minus 2. So 6 by minus 2, it is minus 3, it is 4, minus 5, and 3. Minus 6 by minus 2 is 3. And I should multiply fourth row with minus 1. So it becomes 2, minus 2, 3, and minus 2 into A. So if you observe carefully, this has been reduced to identity matrix. Whatever the given matrix, okay, this has been reduced to the identity matrix, and this is B into A. So this is in the form of, after reducing, it is in the form of I4, since it is a 4 by 4 matrix, is equal to B into A. Now what is B matrix here? B is nothing but, we call it as inverse of A, that is A inverse is equal to minus 3 3 minus 3 2, 3 minus 4 4 minus 2, minus 3 4, minus 5 3, 2 minus 2, 3 minus 2. So this is the final answer. Is that clear, students? Just go through once. You have to perform the row operations carefully and the calculation part also. Check this calculation part. See, this calculation part check twice, Nana, so that no mistakes will be done. Check it twice, all the calculations, whatever the calculations you are making in the rough part, check it twice. Okay, students, thank you. For more videos and problems, please do subscribe Sankalp Study Success channel and download the app. In the app, we have lot of solved problems and assignment problems too. Before solving the assignment problems, please do watch my videos, understand the concept, and try to do those problems. Thank you.